Creating stories from distance time graphs. One sunny June morning, Leslie decided to go for a jog. The graph below represents her jog. Write a creative story about the events that occurred during her jog and include as much mathematical terminology as possible. So we need to consider what the initial values and the final values of the graphs tell us. So right here and right here. It tells us that we start and we end at home, and that we end after approximately 30 minutes. We also need to look at the information each section of the graph tells us. So there are 4 distinct motions here. So I labeled them A, B, C, and D. And section A tells us she's moving away from her house at a constant speed. We know it's away because the distance is increasing, and we know the speed is constant because it's a straight line. In part B, the line is not as steep, so it tells us we're going at a slower constant speed, but it's still constant because it's a straight line. And it's still away from the house because the distance is still increasing. Part C tells us she's standing still because it's a horizontal line and the distance from home is not changing. Part D tells us she's moving back towards the house because her distance is decreasing. And if we look, it looks like we're covering the same distance in the same time span as we did in section A, so the speed is now the same. Okay, both those lines A and D are equally steep, but in opposite directions. Can we get more precise information about each section? Absolutely, because we can find the speed of each section, because we know it's linear, so we can just use the formula speed equals distance over time. So if I look at section A, you can see that we go from 0 to 5 minutes for a total time of 5 minutes. And here we go from 0 to 1 kilometer. And so speed is 1 kilometer divided by 5 minutes, or 0.2 kilometers per minute. So we can say that she is moving at a speed of 0.2 kilometers per minute, and we can say that's away from home. Okay, the distance is increasing at a rate of 0.2 kilometers per minute because the line rises to the right. In part B, again, the time is 10 minutes, the distance is 1 kilometer. So 1 kilometer divided by 10 minutes tells me it's 0.2 kilometers. Or sorry, 0.1 kilometers. So again, her speed is 0.1 kilometers per minute, and it rises to the right, so the distance is increasing at a rate of 0.1 kilometer per minute she jogs. Part C, the distance from home doesn't change at all, so it's 0 divided by 5. And we know that 0 divided by anything is 0. So her speed is 0 kilometers per minute. And since the speed is 0, it tells us our distance is not changing, which tells us she stopped jogging. And then we'll look at the rate of change of distance with respect to time in segment D, and that will be -2 kilometers in 10 minutes because she just traveled 2 kilometers towards home, so the distance was decreasing, so we used a negative value, and the time was 10 minutes. And a negative divided by a positive is a negative, and that makes sense because we're losing. Negative tells us a decrease. Oops, sorry guys. So her speed is -0.2 kilometers per minute. The line decreases to the right. That's what told me it should have been negative because it's a decreasing distance. Now we need to put our story together. So you can create whatever you want, and since I like Narnia, I've written a story about Narnia. Said Leslie went through the wardrobe into Narnia. She was jogging to see Mr. Thomas at a constant speed of 0.2 kilometers per minute. After 5 minutes, she was getting tired, so she slowed down to a constant speed of 0.1 kilometers per minute. She reached Mr. Thomas's house 15 minutes after she entered Narnia. She had tea with Mr. Thomas for 5 minutes and then heard Susan calling her from the wardrobe doors. She gulped her tea and ran at a constant speed of 0.2 kilometers per minute back to the wardrobe to find Susan.